integration. Okay, so here we are in numerical integration. We'll just go to the definition. The process of evaluating a definite integral from a set of tablet values of an integrand f of x is called numerical integration. So what this says that you are not going to use the integral sign, means you are not going to use the actual integration, but by using some data you are going to calculate the integral value. This is what we have, the very good application that we will going to find here. So in this numerical integration we will come across Newton's, this is Newton's Cotes quadrature formula. What is meaning of this, students? It says that there is, if you take the x-axis and y-axis, and graphically you can understand very easily this. So I will take I is nothing but some integral, right? So I will take a curve here from A to B. I will take one curve, and under this curve I am going to calculate the area. So I want to calculate the area under this curve, right, students? So you can see this is also helpful to find the area of a circle is there, rectangle is there, right? So even this is also helpful nowadays for plotting. Yes, so plotting of any area, now plots are there, right? Some Buddha plots are there, many other plots are there, government plots are there, society plots are there, they also use this. It is also helpful for them to use this method. And you can also see roads nowadays, students. You can see roads area also is calculated by using with help of this only, students. Okay, so I'm going to take now integral A to B. Under this area I want to calculate from this curve, so I will take a curve y is equal to f of x. Then I will start taking the straight line. So I will take the first x naught. I will start from x naught, corresponding value will be y naught. Okay, then I will increase this by some interval h, x naught plus h, and corresponding value will be y1. Next value will be x naught plus 2h. Again I am going to increase the interval, corresponding value I am going to get y2. So I'm going to find the area under this curve, students. So same way this will continue till yn. So whatever the area will be, I'm going to calculate the approximate area, student. By use of this is very important, that is we are going to calculate the approximate area. So we are going to divide this area into n intervals under the curve A and B, taking y is equal to f of x is the function. So here I will take the integration I, and this is equal to, this integration starts from x naught to x naught plus nh. So this function I'm going to take as y is equal to f of x dx. So this is how we have to construct the integrand. Then this is equal to, we will just simplify this by putting and substituting value. We are not interested in the derivation here. So by using Newton's forward interpolation formula, you have seen the interpolation formula, you are going to take the differences, right? And you are going to use the finite difference for y0, y1, y2 till yn. You can see you will get this equation, that is this is equal to h, integration from 0 to n, intervals we have taken, therefore 0 to n, and this equation we get, which is known as Newton's forward interpolation formula. We get this, students. Okay, so next we'll just integrate this now. Then you can see we get this equation A. So simple integration is there, but we are not interested in solving this derivation. Okay, so this is known as Newton's Cotes quadrature formula. From this general formula we deduce the following important quadratures rules by taking n is equal to 1, 2, 3 and so on. So by using this formula we will be taking the quadrature rules, students. Okay, so the first rule, when I substitute n is equal to 1, so please remember this lines, and in between these lines is nothing but the strips. So what we are doing, actually I will tell you, see, I'm going to take the area under this curve, taking x-axis and y-axis. I'm going to take the strips so that I get the approximate area. Suppose if I want to calculate the whole area, I cannot calculate the whole area, otherwise I have to take one any circle is there, right? I get the formula, I'll use it. So it cannot be fit in the circle. If I take the triangle, rectangle, if I take any shape I take in the geometry, I will get one some formula and I can use. But in this area I cannot fit any of these shapes. So therefore this is an idea that I will take the strips, so that I will divide this into n intervals, that I will get the approximate value. So therefore I will take first one by one strips, that is n is equal to 1. Here I am going to take n is equal to 1. I'm going to put it in this Newton's quadrature, Cotes quadrature formula, equation A. So put n is equal to 1, taking the curve through x naught, x y naught and x1 y1 as a straight line, that is polynomial of first order, so that the difference of order higher than first becomes
Sir,
0.
scroll up one, sir.
Yes, beta. Yes. So what we are going to do here, in this formula, I'm going to substitute n is equal to 1. Means I'm going to take from this curve. Have you written it?
Yes, sir. Thank you.
Okay, thank you. So what I'm going to do, I will tell you. I'm going to take the 1 strip. That is the meaning of n is equal to 1 is I'm going to take one strip, two strip, next strip. I'm going to add again. I will take one strip. I will add. I will take next strip and I will add. Corresponding values will be like this: integration from x naught to x naught plus h, f of x dx is equal to h, y naught plus 1 upon 2 delta y naught. So what I am doing here, I am going to put here n is equal to 1. So y naught plus 1 upon 2 delta y naught. Higher orders will become 0. Okay. So only first difference I will take every time. Then I will go to the next strip. I will take the first difference. I will go to the next strip. I will take the first difference. So like this, all these strips one by one I will take, and ultimately I will add. So that will give you the integral from x naught to x naught plus nh f of x dx is equal to h upon 2 y naught plus yn plus 2 times y1 plus y2 plus dot 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 yn minus 1, which is known as trapezium rule. So why this is known as trapezium rule, you may ask me. So I will tell you that the areas of each strip is found separately, right? I'm going to take area of every strips, and at the end I will add them. Then the area under the curve and the ordinates at x naught and x naught plus nh is approximately the area to the trapezium. So it is equal to the area of trapezium. Therefore, this is known as trapezium rule. So please remember this, friends, which is helpful for solving the example. Next, what I will do, I will go to the next rule, that is Simpson's 1/3 rule. Here, what I will do, I will now going to take the again the same area under this curve y is equal to f of x. Now every time I'm going to take two strips. Means in first I will take two strips. In next I will add again two strips. It will become 4, and again I will add two strips. It is going to become 6. Like this, every time I'm going to take two strips and add continuously. Then corresponding values I will get here. For the first two strips, it will be x naught plus 2h f of x dx is equal to this value. So again I will going to put n is equal to 2 in this equation A, that is Newton's Cotes quadrature formula. I will substitute, and you can see I will get this first corresponding value. Then second I will add next to two strips, next two strips I will add, students. Like this I will continue this process. Then I will get the Simpson's 1/3 rule formula, that is x naught integration from x naught to x naught plus nh f of x dx is equal to h upon 3 y naught plus yn plus 4 times y1 plus y3 plus dot 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 yn minus 1 plus 2 times y2 plus y4 plus dot dot yn minus 2. Okay, so while applying Simpson's 1/3 rule, please remember the given interval must be divided into even numbers of equal subintervals, since we find the area of two strips at a time. As I told you, first I will take two strips, I will calculate the area. Then plus Again, I will take two strips, I will calculate the area and I will add. So like this, at a time, I will calculate the area and I will add. So this process I will continue. Okay, okay. Now what I will do, I'm going to put n is equal to 3 in equation E, that is Newton's Cotes quadrature formula. So what I'm going to do here, students, how I'm going to calculate the area under the curve. Three strips I will take and I will calculate first area. Then I will take again three strips. Again I will calculate the area and I will add it. So like this process I will continue. So this process I will continue. So this process
So
is
why
known as,
one second?
at a time I will calculate the area and I will add. So the first three strips. Yes, beta. Yes, please ask your question. Okay, any doubt? Please ask me. Okay, fine. So what I am doing in Simpson's 3/8 rule, I'm going to take three strips, I will add. So first three strips is given as integration x naught to x naught plus 3h f of x dx is equal to, this is 3h y naught plus 3 upon 2 delta y naught plus 3 upon 4 delta square y naught plus 1 upon 8 delta cube y naught. So here delta cube, delta square, delta cube, we will be taking as y1, y2 and y3. So don't get confused. 3, now I will get the first three strips is equal to 3h upon 8 y0 plus 3y1 plus 3y2 plus y3. Similarly, I will continue this process. Okay, so you will get the next nth term will be similarly, so on, it will be continuing like this. So all these strips I will add at a time now. So it will give you Simpson's 3/8 rule, which is nothing but integration x naught plus nh f of x dx is equal to 3h upon 8 y naught plus yn plus 3 times y1 plus y2 plus y4 plus y5 plus dot 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 yn minus 1 plus 2 times y3 plus y6 plus dot 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 yn minus 3, which is known as Simpson's 3/8 rule. So while applying Simpson's 3/8 rule, students, remember the number of subintervals should be taken as multiple of 3. So I already told you in this curve now, just I am taking different strips so that to get the approximate value. Therefore, we are using this different rules. Okay. So next rule is wedge rule. So what here it says, now when I'm going to take putting n is equal to 6, students. So now what I'm going to do, in first case, I will take 6 strips and I will calculate the area. Next step, I will take again 6 strips and I will calculate the area and I will add to the first 6. So it is going to become 12. Next, it will become 18. Next, it is going to become 24. This is just a rule for different strips. So if you continue in this process, you will get this integration from x naught to x naught plus nh f of x dx is equal to 3h upon 10 in the bracket y naught plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus 2y6 plus 5y7 plus y8 and so on. This is known as wedge rule. So please remember the number of subintervals should be taken as a multiple of 6. It is more accurate than any of the other rules, students. So I'm going to take every time 6 strips. Okay, so please remember this 4 formulas. So this is important for our study and we are going to use, by using this rules and formulas, we are going to solve the problem. So you can note down this trapezoidal rule. So I is equal to, I is nothing but any integration function, right? Integration from x naught to x naught plus nh f of x dx. Okay, so this is I is equal to h upon 2 y naught plus yn plus 2 times y1 plus y2 plus dot 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 yn minus 1. Simpson's 1/3 rule, I is equal to h upon 2 y naught plus yn plus 4 times y1 plus y2 plus dot 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 yn minus 1 plus 2 times y2 plus y4 plus dot 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 yn minus 2. Similarly, we have Simpson's 3/8 rule and a wedge rule. I will tell you how to remember this formula. At a time, it is very difficult to remember the formula, because when I was studying, I was also finding this difficult. So what I did, I used to remember the formula like this. So first, every time, this is first value plus last value I used to add. Then this is plus 2 times remaining values. So I used to remember like this, students. This is h upon 2 will be there, and this is how you have to remember. Okay, in the interval you will understand why I'm telling like this. Okay, so next, how you will remember again this Simpson's 1/3 rule. This is again h upon e, right? Okay, this is first value plus last value, add them, plus this is 4 times. Yes, students, please remember these are odd. What are odd? Odd means y1, y3, right? y5 is there. Like this is odd terms. You can say odd terms are there. Then plus 2 times. You can say this is y2 plus y4. Next will be y6. This is even terms. So this is how you have to remember the formula. So I know it is difficult to remember the formula. Okay, next you can see this is 3/8 rule. So this is 3h upon 8 interval. Again, how you remember your formula? First term plus last term. Okay, in the interval you will understand how to get the interval. This is 3 times. Yes, all terms you have to write here, but leaving multiple of 3. Okay, I will write here just multiple of 3, plus you can see this is 2 times. Yes, 2 times. This is multiple of 3. I will tell you how it is multiple of 3. So you can see this is y6, y3 plus y6, y9 you will get here. And here only that multiple of 3 living, you should leave that. So y1 is there, y2 is there, y3 is not there. Okay, y3 is not there in this. Then y6 will not be there, because that will be plus 2 times this multiple of 3. This is how you are going to remember. Wedge rule, see, it is completely different. So I tell you to remember like this. I will take some k value and I will substitute 1, 5, 1, 6, 1, 5, 2, 5. So again 1, 5, 1, 6. This process will continue, students. Now you can see only the coefficients I have given. K is nothing but coefficients. You can take this as y0, y1, y2, right, y3. Like this, you can continue on this process. So you can add them and remember like this. 1, 5, see, y0 plus 5, y1 plus y2 plus 6, y3 plus y4 plus 5, y5 plus 2, y6 plus 5, y7 plus y8. Next term will be what? Yes, it is plus y9 plus 6, y10. So this process continues, friends. Okay. So like this, you can remember Wedge's rule. So this is 3h upon 10. Okay, next. Yes. So in the example, students, they will not give the interval. So this is the formula I'm going to remember the interval. The interval is given AB. So AB interval is how? That is integration of lower limit A, upper limit B. That is the area you are going to cover, or you are going to calculate under the strips. So is divided into n equal parts by width h. So please remember width is h, that is the interval, right? Where h is given by b minus a upon n. So this is upper limit b minus lower limit a divided by how many strips are there? Equal parts. So that many we are going to divide this by n. So this is a small idea about how you are going to solve this example, students. So we are going to solve today. This is very important example, students. Please note down and we will simplify. If you have any doubt, please tell me. So maximum in all the examples you can see, you you're going to write trapezial rule, Simpson's rule, Simpson's 3/8, Wedge's rule. Okay. So we'll simplify now, students. Very, very important. Please write it down. Solution. See here again, the step one. Please remember, I have not given the steps here. But first step, given data. First, you have to take the given data. What is given? Only integral 0 to 6 is there. I will write like this instead of this 1 upon 1 plus x square. I will take here dx. I will take. Okay, I will take this as equation 1. Okay, but please remember here f of x, that is our function, is 1 upon 1 plus x square is there, and I will also calculate h. H is nothing but b minus a upon n. So how you will take now n? That is also important. Yes, so b I will take here this as 6 minus 0 divided by. How many intervals you will be taking here, students? Please remember, I will be taking here intervals 6. So that this is going to become h is equal to 1. So why I have taken this 6? Because please remember, trapezoidal rule already you know, it must be even, right? Simpson's rule must be even, and please remember minimum 6 are required to simplify Simpson's 3/8 rule. Yes, 6, it is multiple of 6, right? So Simpson's 3/8 rule, at least 6 strips must be there, no? Is it clear? Have you understanding? Please reply, beta.
So please tell once again.
Okay, once again I will tell you. Okay, no problem. Okay, very good that you're asking once again. See here, given data is there, integral 0 to 6, 1 upon 1 plus x square dx is there. This is there. I will take equation 1. You can see f of x is equal to 1 upon 1 plus x square. Okay, till here it is clear. H is equal to b minus a upon n. This is n. Huh? Okay, this is not looking like n, but please consider this as n. I'm not so writing good handwriting. I don't have. So okay, this is equal to 6 minus 0 upon n. Why I have choose? I will write here. I will have chosen n is equal to 6. Why I have chosen n is equal to 6? Only one clue I will tell you. Remember, Simpson's 3/8 rule is given to find. This is enough. What Simpson's 3/8 rule says, you are going to take 6 intervals at a time. So obviously n must be 6 parts. Now is it clear?
Yes, sir. Thank you.
Yes. So this is how, there are some tricks I will tell you to remember so that it will helpful to simplify the problem. So n is equal to 6 I will take. Therefore, interval must be 1. Okay. Now I will tell you. I will take the intervals now. So step 1, all these things you have to remember, students. Okay. So I will take now x and I will take the y value. This is our y. F of y is equal to f of x. Do you remember, right? I'll write here only. Y is equal to, this is f of x. This is the curve, students. Please remember. Okay, many things are there here. Okay, slowly you will understand. Not suddenly everything you will not understand. You have to go at least 2 to 3 times. Then it is easy to understand this. So y is equal to f of x. So I will take x and y. I will write here also f of x only. Okay, students, so please be ready with the calculator. Even I will take the calculator and sit. Yes, first I will start with 0. Right, there will be 0 is there. Substitute in this value. I will show you 1. So this is, you have to calculate like this. I will do it here only. 1 divided by 1 plus 0. Okay, so this will be equal to 1. Is it clear? Will you please go with the 1? Substitute 1 and tell me what is the answer fast. Substitute in this formula.
1 by 2.
Yes, 1 by 2. I want approximate value. Therefore, I will take 0 0.2. 0 0.5 is the correct answer. Very good. Beta, go for 2, please.
1 by
1
5.
divided by 1 by 5, or you can take this as 0 0.2. Then go for 3.
0.1.
1 by 10. Yes, it is 0.1. Very good. Okay, go for 4. It is orally, you can do it here. You can see 1 divided by 1 plus 4 square. 4 square 16. 16 plus 1 17. So 1 divided by 17 is
0.058.
5, 8, 8 you can take. Okay, then you go for 5. Then you can see 1 divided by 1 plus 5 square is 25. 25 plus 1 26. 1 divided by 26.
0.038.
38. Yes, very good. So you can take another value 5 also. Similarly, we'll go with 6. So 1 divided by 1 plus 6, 6 square 36, 36 plus 1 37. 1 divided by 37,
0.0270.
270. Yes, beta. So here we have to get the this data first. Then you are going to write here, this is our y0, y1, y2, y3, y4, y5, and y6. Now this is clear. Now this is step 1. Okay, all these things you have to remember. First, you have to take the function f of x. H you are going to calculate, and then you are going to write the tables. Is it clear? Okay. Now I will take the first one, that is trapezoidal rule. So what I will do here? Yes, I will just take this formula. So please remember, every time you are going to write this formula, students, very, very important, because these terms will change. I will tell you, I will let you know how these terms will change. Okay, so n is equal to 6 is there. So you should write like this: I is equal to h upon 2. This is y0 plus y6 plus 2 times y1 plus y2 plus y3 plus y4 plus y5. This you have to write the formula, because n is equal to 6 is there. For n is equal to 6. So now you will substitute the values. What is h? Here h is
Sir, why
equal
we have
to,
not considered y6 in the second term? Y1
yes,
is
very
only.
good question, student. Very good question. This is, you can see y6 is already written. I have told you, first and last will be added in the first strip only. If you again add here y6, then strips will increase, then area you will not get approximately. Okay, don't repeat the strips here. So please remember this, first and last have taken here, and remaining terms are in this. So this formula you have to write it, then substitute the values, students. So you can see h is equal to 1 is there, 1 divided by 2. Again, if you just substitute here, n is equal to 6. So you can just, here also you can substitute. The 6 minus 1 will become y5. So therefore, y5 I have taken here, beta. Okay, is it clear? Yes. So
Yes,
here you
sir.
can just substitute n is equal to 6, beta. Okay. Thank you for asking your doubts. So please ask your doubts, students. Don't keep your doubts in your mind. Okay, now substitute here. Y0 is 1 plus y6 is 0.270 plus 2 times y1 is 0.5. Just
Sir, it's
substituting and telling.
0.0270. You missed the
Huh.
zero in between. Y6, sir.
Oh, sorry, sorry. Yes, you are right. So in hurry, I have made it 0.0270. Okay. So plus 2 in the bracket 0.5 plus y2 is 0.2 beta. Then y3 is 0.1 plus y4 is 0.0588 plus y5 is 0.0385. Just add and tell me the answer. Yes, please tell me what is the answer.
1.4108.
Yes, very good. It is 1.4108 is the correct answer. So everyone, please try. Don't wait me to solve. Everything is there. So just copy down and simplify. So I will take the next one. Here we go. So again here, please remember n is equal to 6 is there. Please, you have to at least write this formula. It is h upon 3. So first term y0 plus n is equal to 6, y6. Okay, so plus 4 times. Please remember here remain odd terms are there. So odd terms in y0 to y6 are y1, y3, y5. Okay, I cannot take y6. I have written already. Y7 is not there. Therefore, finish. Plus 2 times even terms. That is y2 plus y4. Again, y6 I cannot take because I have written here y6 already. So this complete. So this formula you have to write in the exam. Huh? Please remember, marks are allotted for this. Okay. Then take h value. Substitute h is 1 and this is 3. Why not? You can write here 1 plus y6 is 0.027. Substitute the values now. This is 4. Y1 is 0.5. Y3 is 0.1. Y5 is 0.0385 plus 2 times y2 is 0.2 plus y4 is 0.0588. You can take. Yes. Now substitute and tell me what is the answer.
1.3662.
Okay, it is 1.3662 is the correct answer, beta. Yes, very good. So you are fast than me. Okay, yes, very good. Now I will go to the Simpson's 3/8 rule. Okay, so I will go with the Simpson's 3/8 rule. Yes, beta, I rewrite the formula for n is equal to 6 first. So I is equal to, this is 3h upon 8, right? Therefore, this is known as 3/8 rule also. So I will write here y0 plus y6 plus 3 times. This is values without multiple of 3. Please remember. Therefore, I will write here y1 plus y2. I cannot write here y3. Okay, I will go with y4 and y5. Y6 I have already written. Therefore, this will finish here plus 4 times 2 times yes 2 times here only y3 will be there because y6 I have already written. This is multiple of 3. You should write in this bracket. Therefore, now substitute the values here, students. 3 is there, h is 1. Okay, 1 is there. Substitute the values here. So y0 is 1, y6 is 0.027 plus 3 times y1 0.5, y2 0.2 plus y4 0.0588 plus y5 0.0385 we can take of plus 2 y3. Y3 is 0.1. So please tell me what is the answer, students.
1.3570.
Yes, very good, beta. It is 1.3571 is the correct answer. So please simplify, substitute, and you will get the answer. I'll go to the next value, that is fourth one, Wedge's rule. Okay, so I will substitute the values here. Here I have Wedge's rule. Okay, now rewrite the formula like this. N is equal to 6 I will take. So this is I is equal to 3h upon 10. So remember 6 means till here I should finish. Okay, so I'll write as it is y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus 2y6, students. So till here you have to substitute the values now. So I will substitute the values one by one. This is 3 bracket 1 divided by 10. Okay, y0 is 1 plus 5, y1 is 0.5 plus y2 is 0.2 plus 6, y3 is 0.1 plus phi u. Y5 is 0. Y4 I missed. So Y3 over Y4. Y4 is 0.0588 plus 5 times Y5 0.0385 plus 2 times yes. So is the presenting screen is visible?
Yes, sir. Yes, sir.
Okay, beta. Thank you for your reply. Next, so after calculating all the values, now I will take the last one. It is comparing the result with the actual result. So we will just see this. Okay. So how you will compare? Just see here. So what is the question given here? I will just do the direct integration. So actual integration I will do in the last part. So this all approximate values will be compared with this now. So this is 0 to 6 dx upon 1 plus x square is given. So this is equal to, so can anybody tell me what is integration of this 1 upon 1 plus x square? Please remember it is tan inverse x from 0 to 6. So now substitute here and tell me what is the answer. Otherwise you can go to the calculator also. I think that will be easier for everyone. Just go for where is the integration, right? And I will take here 1 divided by 1 plus,
Sir, 1.4056.
yes. So it is 1.4056. Please check the values answer, students. Integration from 0 to 6, 1 divided by 1 plus x squared. Is the calculator visible, students?
Sir, not clearly.
Okay. I will send this screenshot of this. Okay. I would have taken this
We
before
got,
only.
sir.
Okay.
Okay, sir.
Fine. So now you can see which one is very nearer. 1.38, 1.35, 1.36, 1.41, 108 this is. So which one is nearer to 14056? Anybody? Please check. So more probably Wedge rules will be very much nearer to the answer, students. Okay, so like this you should able to simplify the problem. So now next problem is there. Will you solve this problem?
Sir,
Yes,
what to
students.
write that conclusion? The wedge rule more appropriate. Or what?
Conclusion means this is the conclusion. We have to find all the approximate values from this. So what you come to the point is that which one is nearer? Yes, you can see all the answers are nearer to the actual answer. This is one. Second one, very, very nearer will be Wedge rule. That is parts we take at a time. Therefore, this is very nearer to the actual answer. So now I can see with integration, without integration. But you can just see this with integration, you can do it very easily. But in area wise, strips, if you take, this is helpful for strips. I cannot integrate every strip. Am I right? So therefore, this is indirectly, we have taken one function and we have calculated this and we have proved that their actual value is nearer to this rules. Similarly, if you take the area will not be given like this function. Dx upon 1 plus x square will not be the function, right? Therefore, these rules are helpful to calculate the area is there, like mapping is there. Is it clear? So this is helpful for constructing the buildings are there. This is helpful. So area wise, area one by one bricks also they will take and they can calculate the approximate value, how much area is required. Is it clear, students? So will you solve the next problem? Yes?
Yes, sir.
Okay, please try and solve and send me back. Or shall I give the answer?
Sir, you just mentioned the answer. We can compare and
Okay, you
compare.
please try. Okay. So for Simpson's 1/3, first one A, you will get it 0.346. And for B, it is 0.3466. So it is nearer approximate values. You will get. Yes, students, thank you so much. So we will continue in the next class.
Sir, that consider 7 ordinate means strips will be n equal